Okay, this video deals with simplifying square roots. You've seen stuff like this before where somebody asked you to square root 16, and assuming you know pretty much basic multiplication, you know that that is equal to 4, because 4 times 4 is what it takes to get 16. So the square root is the number that you square to get this number. That's not too difficult. Okay? In fact, even if you have square root of 81, you get 9, because you know, hopefully, that 9 times 9 is 81. By the way, sometimes people ask, shouldn't you say plus or minus 9, because both positive and negative 9 square to get 81? I agree, except when you see this root sign, it automatically assumes that you mean the positive square root. So we'll just say 9 or 4. So what happens, though, when you're solving some problem and they say simplify the all square roots or radicals, sometimes you hear that, as much as possible. And we've seen a couple of different methods to do this. Some people say, well, look, I know that 4 is a factor of 40, and that's a perfect square. So if I just simply wrote that as square root 4 times square root 10, that would get me to square root 10. And that works just fine. I like using that method a lot. One of the problems people have, though, is what do you get to? Where do you go when you simplify the square root of 96? Well, if you happen to remember that 96 can be, 16 is a factor of 96, then that works out okay. You could say, well, it's 4 root 6. But sometimes they get a little bit more complicated than that. It can be difficult to approach. So I've got a method that I like to use that maybe is a little more tedious than this, but it works every time. And you know, I use some shortcuts like this, other kinds of things, but this method works pretty nicely. So suppose you're asked to do the square root of 72, and you don't recognize that both forget that. You don't recognize a perfect square that's a factor of this. So what I'm going to do is say, look, let's first take 72 and let's break it up into all of its possible factors. You've probably seen two different methods to do that. One is a tree diagram, and another one is some people call it a ladder. Here's the way both those work. If you take 72 and say, well, what numbers multiply together to get 72? You get, for instance, 9 and 8. Well, are there any numbers that multiply together to get 9 and 9? Well, yeah, 3 and 3. So we'll break it down further. What multiplies together to get 8? Well, 4 and 2. Okay. Do any of these get broken down any further? Not 3 there, because those are both primed. 2 is primed, but hey, 4 can be broken down into 2 and 2. So now you've got 2, 2, 2, 3, and 3 that are all factors of 72. Another method that I like to use more is say, look, what's the lowest possible prime that you can divide 72 by? Well, it's 2, and you get 36. Can you divide by 2 again? Yeah. You get 18. Can you divide by 2 again? Yeah. You get 9. Can't divide by 2 anymore, but what's the next prime that I could divide by? Well, 3. And you get 3. Since 3 is a prime number, here's your factors. 2, 2, 2, 3, and 3. So it doesn't matter how you do it, but you just need to get these factors all listed out. I like to list them in numerical order, so I'm going to look at it this way. 72 could be written as 2, 2, 2, 3, 3, all underneath the square root sign. And then take a look at what happens here. I could break this up into pairs. There's not another pair there, so I'll just write a 2. Here's a pair of 3s. Kind of sounds like I'm playing poker, but when you look at it this way, 2 times 2 is 4. Square root of that is 2 again. Can't simplify square root 2 anymore, but look at this. 3 times 3 is 9. Square root of that, you get 3. Multiply these together if you can. 2 times 3 is 6, so you get 6 square root 2. Yeah, there are quicker ways you could have done that if you recognize that 36 was a factor of 72 and a perfect square, but hey, this worked. So suppose you get something like square root 40, and you don't realize that it could be simplified, that 4 is a perfect square and a factor of that. So we step over here and we say, I'm going to use the ladder method. I'm going to divide by 2. I get 20. I'm going to divide by 2 again. I'll get 10. I'll divide by 2 again, and I get 5. So this could be factored, written out as 2, 2, 2, 5. Here's a pair of 2's in here, so you could write it as 2 times 2 times square root 2 times 5. I just broke it up into pairs here. And so now 2 times 2 is 4, square root of that, you get 2. This can't be simplified over here, so I'm just going to rewrite it as 10. And now I'm done. In fact, what I do is I look back over here and say, you know what? There's a pair of 2's right in here, so that means I'm going to write a 2 outside. And I just multiply the other things back together. And sometimes I'll even just circle up here. Pair of 2's, that means a 2 comes out. 2 times 5 is 10. I'll leave that back inside. So if I get something like square root of 180, if I don't recognize any perfect squares that are factors, I'll just say, well, divide by 2, you get 90. Divide by 2, you get 45. Can't divide by 2 anymore, but I can divide by 3. I get 15. I can divide by 3 again, and I get 5. Since 5's prime, I'm done. And I look over here and say, that pair of 2's means I can take a 2 outside. That pair of 3's means I can take a 3 outside. There's a 5 inside, so I'll just leave it like that, and the answer is 6 root 5. So it's a real nice process for getting through these things. So what about having 90 x to the 3rd power? Square root. Well, let's break down the 90 first. 90 divides by 2, you get 45. Can't divide by 2 anymore, but you can divide by 3, you get 15. Divide by 3 again, you get 5. And I'll look and say, well, there's a pair of 3's, so that means I'll have a 3 outside. Well, take a look at that x. That x is really just x times x times x, and here's a pair of x's. So I'll take an x outside as well. Okay. What's left over inside? Well, there's still this 2 and 5 right there, so I'll multiply them together and get 10. And there's still an x from over here, so I'll leave it as 10x. And now I'm done. So let's just come up with some awful looking beast and see what we can do with this thing. Let's try 54, and then how about x to the 5th and y to the 6th? Okay. We'll talk later about where you would ever possibly do something like that, but we're just going to simplify this, make sure we got the skill down. So first let me take 54. It does divide by 2, and you get 27. That divides by 3, you get 9. And that divides by 3, and you get 3. So I'm going to look and say, well, here's a pair of 3's right there, so I'll have a 3 outside. Okay? The x times x times x times x, the x to the 5th right here, really is going to be this. And there's a pair of x's, there's a pair of x's. So I'll actually take 2 x's outside, x times x, I'll just write x squared. And then there's the y to the 6th, that's really going to be just 3 pairs of y's. So that means I'm going to have 3 y's that I take outside. And then on the inside, I still have this 2 and 3 right here. So I'll multiply those together right, and get 6. I still have an x left over here, so I'll write that. All the y's came out, and so now I'm done. So I just look for pairs of things and take them. Anytime I see a pair of something inside the square root, it means I can take one of them outside. Yes, there are quicker shortcuts. I could have recognized up here in 54 that, yes, 9 is a perfect square and it's a factor of 54. So I could just take a 3 outside and leave a 6 inside. I get that. But if you want to have a nice process, this works fairly nicely.